All right, P3. P3, we're going to continue on working with fractions. And first thing we're going to talk about, though, is something called prime factorization. Because you need to know prime factorization so that you can reduce fractions. So what is prime factorization? If we have number 45, what are two factors of 45? 5, 9. Now what is a prime number? A prime number is a number that cannot be found with any other factors except for 1 times itself. So 5 is a prime number because the only thing that you can get to multiply to 5 is 1 times 5. So there's our first prime. But is 9 a prime? As long as you can think of one other combination that multiplies, then it's called a composite number. It can be broken down further. Well, 9 can be broken into 3 and 3. Is 3 a prime number? Yes. So there's our prime factors. How is it written? 3 times 3 times 5. And we do put the dots for multiplication, especially just so you know, when you're doing the keying homework into the program, it does take that. There will be a key, an extra little key thing there that pops up. So let's try another one. $36. Well, 36. If you're not real sure, you can always divide by 2 because it's an even number and whittle it. So 2 times 18. 2 is prime. 18 being an even number is not. The only even prime number is 2 because after that, definition of even is divisible by 2. So only even 1. So we got another even number. It means I can take out another 2. And then we got 3 and 3. The most common prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 37, and it keeps going. The list is infinite. You can always Google it, prime list, and they'll take it out a lot further than that. But for us here, that's a decent list for prime numbers. So if you need, take a chance to write these down. These are primes. Okay? So let's apply prime factorization to reducing fractions. So let's look at 36 and 45. I can break these down, or I can break out the prime factors. Now let's look at this. Both have a 3, so we can cross out the 3's. What do I have left? I have a 5 and 2 2's. So the 5 is on the bottom, and 2 times 2 is 4. So 36/45 reduced to 4/5. That's using something called this, and by the way, these are called trees, factorization trees, because you see how it has all the little branches. But if you can cross a number here and here, That takes it out, because that means that is a factor of the original number. Let's try another one. $150 over 180. Well, they both end in zeros. So let's start our factor tree. I'm doing it side by side. All right, since they end in 0, I know I can take a 10 out of both. 10 is actually 2 times 5. And 15 is 3 times 5. So I have 2 times 3 times 5 times 5. I'm going to show you how this works, why you can cross out straight from the trees. So let's do 880. Again, it ends in a 0, so I know I can take a 10 out. And that's 10 times 18. Well, there's my 10 and 2 times 5. And I have 2 times 9. Well, 9 breaks down to 3 and 3. So what do I have? I have 2 times 2 times 3 times 3 times 5. That's this prime factors. Each tip is a prime. Now looking at it this way, we have 150 over 180 broken down into its primes. So look at this. 2's are over each other. I have 3's. I have a 5. What do I have left that's not marked out with a bottom number? I have a 5. And down the bottom I have 2 times 3, which is 5, 6. That's how that works. Okay? I apologize. This is I'm going to probably break P3 into 2 different, just so you know. Let's talk about multiplying fractions. When we multiply fractions, top times top, bottom times bottom. However, I describe this like having unruly kids. You don't want the numbers to get really big, because if I go top times top, bottom times bottom, that's what I get. Now I have bigger numbers to factor, correct? Well, what if I factor these? Because I see 3 times 4 times 4. 3 times 4 times 4. 16 is 4 times 4. The reason why I didn't break the 4's down any further, because I'm looking at a 4 on the bottom over here. And 21 is 3 times 7. Well, I can cancel the 3's, and I canceled the 4's, and what do I have left? 4 7's. Some of you have been taught, and you may have confused students, like, well, what do they mean by crisscross? The crisscross is, I already know, I can divide 3 by 3 and get a 1, or 21 by 3 and get a 7. 4 divided by 4 is 1, and 16 divided by 4 is 4. And then go 1 times 4 is 4, and 1 times 7 is 7. Students see that happen, and I did it real quick because they're like, but how did you know? Well, it's because I can break the numbers down into factors. Top times top, bottom times bottom. So let's see this again. Let's try that one. All right. Top times top. Both are prime numbers. Bottom times bottom. So let's break the bottom into its factors. Top doesn't factor, but the bottom does. I see a 4 times 3 for 12, and a 2 times 5 for the bottom. Looking at it this way, my 5's cancel, my 3's cancel, which most students would say the answer is 8. No, I can't say there's nothing left on top, because 3 and 3 leaves a 1, and 5 and 5, they make 1. 5 over 5 makes 1. So my top number becomes 1, while my bottom number becomes 4 times 2, which is 8. So 5 twelfths times 3 tenths equals 1/8. Okay? This is multiplication, and this is where to keep the video, try as best I can. It's 11 minutes at this point, so I'm going to call it quits and do a part 2. Take a break.